All right, welcome to our first math lesson for the week. Today we're doing lesson 6.4, which looks like this. Okay, there's nothing much to write on the first page, and then the second page looks like this. And I will post my solution to the second page, and we're going to go over that example as well. This is pretty much just continuing to look at examples of sine functions or periodic functions in real life. Similar to the one we did where we looked at the phases of the moon. Okay. Our first page pretty much goes over a sine function. Let's just do this up here. So we have a sine function. Right? That's one cycle, but of course this is going to go on and on and on through both sides. Okay. But let's look at just one cycle. Now one cycle, which goes from here to here, will range from 0 to 360. And our x-axis is actually measured in degrees. So x-axis goes from 0 to 360 degrees. Okay, on the y-axis, we go between 1 and -1. Now this is our basic sine function. We can transform this. We can stretch it or make it thinner, which is something we'll do. We can also stretch it this way, right? But your basic y equals the sine of x or the sine of theta looks like this. Okay, a couple key points is down below where it says the y value increases between the x values of. So where's the y value increasing? So if we're looking at this, here it's going up. So here it's increasing, but then it starts to decrease. Over here it decreases. Going lower, lower, your y value is getting smaller, smaller and smaller until there. And then it starts to increase again. All right, so it says where is the what values of x is the y value increasing? Well, it's increasing here, which is between 0 degrees and 90 degrees. And it's increasing here, which is between 270 degrees and 360 degrees. Then it says, where is the y value decreasing, or what values of x is the y value decreasing? That happens in this whole middle section here, which will be between 90 degrees and 270 degrees. Okay. Now the next page looks at another example. It says, example number 1, Jacob is swimming lengths in his pool. His coach is standing at the side of the pool, halfway between the ends, and recording his distance from him. Okay, let me just get my pen. Okay, halfway between the ends and recording his distance from him. Him meaning the coach. The graph of his progress is shown below. Okay, and his meaning Jacob. Okay, so distance, so our y value is distance from the coach, and our x value is time. So over here, it looks like our swimmer Jacob is starting right where the coach is, because their distance from each other is 0 meters. So it looks like Jacob is starting in the middle of the pool. Then he swims to one end of the pool, which it looks like one end of the pool is 20 meters from the middle, and then goes from that end, swims all the way back, past his coach, continues to the other end of the pool. So this sort of tells us from one end to the other end, from plus 20 to minus 20, he swam a total of 40 meters. So it kind of shows us that the length of the pool is 40 meters. And then he comes back over to where the coach is, and then continues. But I'm going to stop there because that is one full cycle. Now, if you want to know the period of this one cycle, how long did it take to go from the middle to one side to the other and back to the middle, or essentially swimming 2 full pool lengths, we started at 0 seconds and finished at 60 seconds. So our period is 60 seconds. Now, if you want, you can go one step further and look at the speed. And speed is just distance over time. So if you travel 2 full pool lengths, which 40 meters, twice that is 80 meters in 60 seconds. So 80 meters divided by 60 seconds, which I wrote down here, which I can't see. Let me move the page. Can't use the pen and move the page at the same time. All right, take the pen off. Don't know how to take the pen off. Okay, so I've moved down the page. Now here, just move this. There we go. Now here in this example, it says the next day Jacob swims in Juanita's pool. Her pool is shorter than Jacob's. Which of the following graphs would represent his distance, and explain why? So let's analyze each one. I've already circled B, but let's analyze each one. Now the first one, if we look at the length of the pool, we're swimming from one end here to the other end there. So from 15 meters from the coach all the way to minus 15 meters from the coach. So we've traveled a whole 30 meters. So the length of the pool is 30 meters. So that's good. Right? That is true. It says Juanita's pool is shorter, and 30 meters is shorter than 40 meters. So, okay, that checks out. But then it says, since it's shorter, let's look at the period. We're going from here all the way there and all the way back in 60 seconds. So the period is 60 seconds. And this is where I thought, so he's traveling a shorter pool in the same amount of time. That means he's swimming a lot slower in that pool. Probably not. I'm assuming he's going to swim the same speed. So if he swam the same speed, he should be able to do it in less time. So, no. I don't think that works out. Okay, and also, where's the coach standing? It says distance to the coach. So if we're starting here, which is 15 meters from the coach at one end, and we swim all the way across to the other end of the pool, which is also 15 meters from the coach in the other direction, it looks like the coach is standing in the middle. I said the coach is standing at the end. Oh, no, the coach is standing in the middle. Okay, really hard to type with the trackpad. I will fix that on the sheet that I post. That's okay. Have a check mark. Okay, so that works out. The thing that sort of bothers me a little bit is the speed. I don't think Jacob would be swimming slower in a different pool. All right, so that sort of analyzes that one. Let's analyze the next one as well, B. And I need to drag the mouse, move the page down, hold on. Okay, so for the next two, so I've scrolled down. For the next two, it looks like this one starts at 0, goes up to 15, and then comes back down to minus 15. So the length of the pool is from plus 15 to minus 15, and so 30 meters, so that is check, it's a smaller pool. But then he's also doing it in a period from here, up, down, and back. Looks like he's doing it in 40 seconds, so less time. Now, if you actually calculate the speed, it's not perfectly the same, but it makes more sense that he's able to do it in less time for a smaller pool. So I like this answer better. And where's the coach standing? Well, if he's going from one side of the coach to the other side of the coach, then the coach is in the middle. Okay, so this one I like the best, so I circled this one. If you look at the bottom one, now this one looks like he starts here, moves up, comes back, and that is one full cycle. One full cycle looks like it is 60 seconds again. Okay, but I put a check mark here because he's traveling at the exact same speed, because it's going from 20 to 40 down to 0. So from 40 down to 0, which means the length of the pool is 40. That's not right. That's not a smaller pool, that's the same size pool. Okay, and where's the coach standing in this one? Well, he's always to one side of the coach. We never go into the negatives. So this, oh, I got this in the first one, so switch. So the coach is standing at the end of, well, one of the ends at the, oh my, well, I'll fix that on the handout that I post at the end of the pool. All right. Now it's good to look at where Jacob, the swimmer, is actually starting from. So here Jacob is starting in the middle, but the okay, didn't know that would happen. Here's Jacob starting is in the middle, and then he goes to one end and back. Now I can't see the other graph. Zoom out. Zoom out. There we go. I'm gone, but so on this graph, it looks like he's starting in the middle as well, but that's also where the coach is. In the first graph was different. The coach was in the middle, but Jacob was all the way up here. So the first graph looked like this. Something like that, where Jacob started at one of the ends of the pool, even though the coach was in the middle. So that's the difference between where Jacob was starting. Alright, now the page on the back, you can't see me, hold on. There we go. Alright, so the page on the back says for each of the two remaining graphs, describe how Jacob would have to swim and where his coach would have to stand. So we've kind of already gone over that. I just wrote all my solutions on here. But definitely go over it yourself, make sure you understand it, and I'll post some homework questions. Later this week, we're going to go over transformations. That's 6.5 and 6.6. And then I'm going to give you a transformation gizmo to work on. And that'll be it for this week, just so you know where we're going. Next week, we'll finish Chapter 6. It's 2 lessons. And at the end of next week, I'll post a quiz based on the assignment, which you can have a week to do. All right.